Good evening and welcome to the Q&A session 10 from the chapter of Semiconductor Devices and Circuits. The topic is the calculation of hole concentration in an extrinsic semiconductor. And based on this topic, I have one question for this session. The question here is: a semiconductor has an intrinsic carrier concentration of 1.41 into 10 to the power 16 per cubic meter when it is doped with 10 to the power 21 per cubic meter phosphorus atoms. So the concentration of the holes at room temperature will be, so we have four options here and we have to find the correct option. So an extrinsic semiconductor is basically an intrinsic semiconductor which is doped with some impurity. Now the impurities are normally the pentavalent impurity or the trivalent impurity. Now here the phosphorus is a pentavalent impurity, that is it has got 5 valence electron. And the intrinsic semiconductors which are normally used in the industry are that of silica or germanium. Now the silica atom has got 4 valence electron. So when the phosphorus atom is dropped in either the silica or the germanium semiconductor, then 4 valence electron. This phosphorus atom has got 5 valence electron. So 4 valence electron forms 4 covalent bonds with the neighboring 4 silica atoms, and 1 electron is now loosely bound to the phosphorus atom. Now this loosely bound electron is now is free to move in the crystal lattice, and because of that we can say that if 1 atom of phosphorus is doped, we will get 1 free electron. So here in 1 cubic meter we have 10 to the power 21 phosphorus atom. So in 1 cubic meter I will be getting 10 to the power 21 free electrons, and here Ne is the number of free electrons in 1 cubic meter. Now we know that Ne into NH is equal to Ni whole square. Here NH is the concentration of holes. Ne is the number of free mobile electrons, and Ni is the intrinsic carrier concentration. So from here the hole concentration will be equal to Ni whole. Now Ni is equal to 1.41 into 10 to the power 16 whole square. So this will be equal to 1.41 whole square into 10 to the power 16 whole square means 32 divided by Ne. Now Ne is equal to 10 to the power 21. So from here 1.41 whole square, this is equal to 1.41 into 1.41. So this is approximately equal to 2. So this is 2 into, now this is 10 to the power 32 and this is 10 to the power 21. So this will be equal to 2 into 10 to the power 11. So the whole concentration will be equal to 2 into 10 to the power 11 per cubic meter. So thank you very much for joining this session. In the next session we will be continuing with the same topic, but the question will be somewhat different from what we have taken today. So till then, have a nice day. Bye.